Hi, my name's Darryl Peterson, and I'm the manager of the Applications Engineering Department here at Micromeasurements. Today, I'd like to show you how to install a strain gauge on a material that maybe you wouldn't normally think of in terms of a gauge installation, and that happens to be a wooden baseball bat. We're going to take a full bridge strain gauge. This particular one happens to have a flex circuit connected already to it, and it's a 4-tab full bridge strain gauge. So we've got our entire Wheatstone bridge right here in this little circuit combined with this little flex circuit that will make it a little bit easier for us to wire it. We're going to take this full bridge, install it onto the handle of this wooden baseball bat so that as we take the bat and we swing it and we make contact with the ball, we can see how much bending strain is in the handle of this bat. We're going to sort of treat it like it's a cantilevered beam. We're going to fix it with our hands down at this point, and it's going to get loaded out here at the end, and we're going to measure that bending strain along the length here in the handle. So let's get started. So whenever you're putting strain gauges on a material that are maybe not a metal, things like composites or plastics, or in this case wood, the first step that you're going to do typically is to degrease it. And we have some solvents that are quite aggressive at degreasing, and they work great on metals. But when you're on wood or composite or plastics, what I like to use is this solvent. It's called M-Line GC6, which is an isopropyl alcohol. This isopropyl alcohol is not quite as aggressive, but yet it's still a very good degreaser, and it also evaporates rather quickly as well. Now, when you're going to use isopropyl alcohol, all you do is take one of your gauze pads, just like this, and I like to take it and fold it, and then maybe fold it again, and take the cap off of the GC6, and just pour a little bit of alcohol into the gauze pad, put the cap back on it, and then just wipe the area around the gauge installation. And in our case, it's going to be down here, getting close to where your hands are going to be on the bat. And I'll just kind of wipe off kind of that whole region where the gauge is going to be installed. Now, since with wood, as we all know, wood has a fair amount of porosity, I like to use a 2-part epoxy. We call it M-Bond AE10. This 2-part epoxy, you mix it up and you got about 20 minutes to use it, but it's a little bit thicker, a little more viscous than, say, a cyanoacrylate adhesive would be, and it's a better filler. So if you've got a material that has some surface texture to it, like in this case, it's got a little bit of porosity to it, I like to use that AE10 because, again, it's a very good filler. So again, a few wipes with the isopropyl alcohol just to degrease it. You know, you kind of don't know where this baseball bat's been, so we'll kind of wipe it down. Now, once we've done that, the next step is to do a light abrasion. And what we're trying to do is create a uniform texture for bonding, and also give it a little bit of texture, and also if there's any contamination on the surface as you lightly abrade, you're going to remove that. So at this point, I'm going to kind of pick a spot where the gauge is going to be installed, and I'm just going to lightly abrade back and forth. I'm using a 320 grit silicon carbide paper, and I'll just kind of lightly, again, go back and forth. And you can cross hatch if you want. Now, once I've finished with the abrasion, the next step, I'm going to take another gauze pad and a little bit of the isopropyl alcohol. Put that into the gauze. And then back and forth, just to kind of wipe off the dust from where we were abrading it. Now, normally the next step is to locate some lines for where the gauge is going to be positioned. In this case, I've already got a mark kind of right here at the edge of the paint that's indicating an approximate gauge location. And really this next step for cleaning, and really the last step that I'm going to do on this baseball bat, is to use the MPrep Neutralizer 5A. This is an ammonia-based solution that helps to chemically make sure that the pH of this surface is at the right level for bonding. Typically we want it somewhere between about 7 and 7.5. Also, it's kind of a final cleaning step. Many times when you're doing gauge installations, we also will use MPrep conditioner. This is a mild phosphoric acid. It's used to help to chemically etch, but we really don't need to chemically etch wood. And in this case, I just don't think that it's really necessary to scrub it with conditioner, so I'm not going to do that. But what I am going to do is finish with the neutralizer, the blue tip bottle. That's the ammonia-based solution. So in order to do that, I'll just apply a few drops of it here on the surface. And then I'm going to use one of these cotton tip applicators. And I'm just going to start scrubbing that area in and around where the gauge and the flex circuit's going to be installed. So I'll just give it a good scrub. Now this is a water-based solution, so it's not going to evaporate nearly as quickly as the isopropyl alcohol. I'll give it a good scrub, maybe one more. And in general, when you're scrubbing with this neutralizer, you want to see that the tip of the cotton tip comes up clean. That looks good. I'll throw that away, and then I'll take a gauze pad, fold it, try to start inside the cleaned area and wipe out, then take it and refold it or find another clean side and go in the opposite direction. And then I'll just kind of wipe off kind of the sides of where we just scrubbed it. Now, basically this surface is essentially ready for bonding. So just to review, we degreased it with the isopropyl alcohol. Then we did a light abrasion with 320 grit silicon carbide paper. We scrubbed it again with alcohol, and then the final step was to scrub it with neutralizer. So now that that's done, I'm going to let it sit there for just a couple of minutes while we start prepping the strain gauge. And anytime you're working on paper like this, once you start to see that the paper gets wet, you can just take it up, fold it, and throw it away. So the strain gauge that we're going to use, again, is a full bridge with a flex circuit on it. Very common application for strain gauges like this is small bending beams. Now in our case, it's not a small bending beam, it's actually a big one, which also happens to be a wooden baseball bat. But we're going to install this full bridge. We're going to get it epoxied on today, and then after we let the epoxy fully cure, we'll come back and connect some wires onto it and then go out and hit some balls and see what kind of output response we get. Now before we handle the strain gauge though, we need to do a little bit of house cleaning. So I'm going to find a piece of glass. This is going to be my work surface. I'm going to lay that down in front of me. And to handle the strain gauge, I got a pair of tweezers I'll use as well. And in general, we just want to clean these up. So I'll take a few drops of the neutralizer, put that on the piece of glass and a gauze pad, and I'll just kind of wipe along the surface of the glass. And also wipe the tips of the tweezers where I'm going to handle the strain gauge. So now I've got clean tweezers. I've also got a clean piece of glass. Next step is we're going to open the package that this gauge is in. We'll lay that out of the way. And I'm going to take this large folder and open it up. And whenever you're handling strain gauges, you really want to try to stay away from the grid area of the strain gauge. So what I'm going to do is handle it, in this case, just by the flex circuit. So I'll just reach in and lightly remove it. There's a good view of it. Again, this is the strain gauge. That is the flex circuit. And we have a whole wide variety of different geometries of strain gauges and flex circuits that can go with that in particular in a volume application, it can really speed up production and make production more efficient. So here in this case, I'm going to turn it on the piece of glass, and what I want to do is take a piece of tape and put that on over top of the strain gauge so that I can hold it in place while I put on the epoxy. And what I'm going to do is I'm going to orient the gauge so that the flex circuit is going to come off to the side. So I'll have the gauge here and the flex circuit running off to the side. And I'm going to have the tape running around the circumference of the bat. So I'm just going to rotate this gauge 90 degrees on the piece of glass, just like that. And now I'm going to put a piece of tape, and if one piece of tape is not wide enough, I'm going to put two on it. And whenever you're handling this gauge installation tape, if it's been a while since you've used it, it's a good idea to tear off the first few inches of it and throw that away because it can pick up some dust. So I'm going to take a piece of tape that's about, I'm going to say roughly 4 to 5 inches long. I'm going to lay that over top of the gauge and kind of wipe it down into place. And the other thing that I like to do, and this might be hard to see, is I like to put a little handle at the end of the tape to make it easier to pick up. Now, in this case, as we look at it, you'll see that I've got the tape over top of the entire sensitive part of the gauge, and I got a little bit of the flex circuit exposed. So I'm going to go ahead and take another piece of tape and just layer that over because I want everything covered as I start to apply the epoxy. No problem with doing that. So I'll take another piece, again about 4 or 5 inches long. I'm going to overlap it on the piece of glass. Run it down here, put a little fold in it, and now you can see it. So I've got the strain gauge and the flex circuit entirely covered with this piece of tape, and actually it's 2 pieces of tape. So as you can see, we've got the entire thing covered. Now, not all adhesives are the same in terms of how they reflow whenever you start the curing process. What we're going to use is a 100% solids epoxy. It's called M-Bond AE10. We're going to mix up AE10 and it will cure at room temperature. Some adhesives, though, will not cure at room temperature, and you'll have to elevate the temperature to get them to cure. And in general, when you're using epoxy-based adhesives that cure at elevated temperatures, you need to allow a path for the adhesive to flow out. So in those cases, you can't cover the whole gauge like I did here. But with this 2-part epoxy, it's called M-Bond AE10, you can cover the complete gauge and put the epoxy underneath. There's no solvents in it that you have to worry about trapping like you do with some of our other adhesive systems. So I've got the tape in place. Now the simple thing to do is to lift the tape. And as we do this, I'm going to lift it at a shallow angle. I'm going to hold it up so you can see it. Once I lift it past the strain gauge, then I can go ahead and peel the tape on up. I'll move the glass out of the way. And then I'm going to take it and apply it here on the handle of the bat. And I'll hold it up so you can see it. So here we have the strain gauge, again a full Wheatstone bridge. There's the flex circuit, there's the tape kind of wrapping around. Here you can see a good view, strain gauge and the flex circuit. Now, if we were to put it on and we didn't like the positioning of it, it's very simple. All we have to do is lift the tape back up, move the gauge where we want it, put it back down. But in this case, I'm looking at it and I think the alignment looks fine. Again, we're going to be measuring the bending strain in this bat as we take a swing at a pitch. So at this point, we're basically ready to start preparing the epoxy. And we're going to use a material that's called M-Bond AE10. It consists of a resin system and a curing agent. This resin system and curing agent, we'll mix them up, and then basically we've got about 20 minutes to use it. It comes with pre-measured jars, and with the resin, all we do is take the cap off and throw that away because we're not going to need it. We've got our type 10 curing agent. This we're going to use with a dropper and a plastic stirring rod. That's the plastic stirring rod. This is the dropper, and we've recently issued some new style droppers too. So if you've got M-Bond AE10, you need to pay attention to what type of dropper you have. This is the older style dropper that uses a pre-measured point for the different adhesive systems. And if it says 10 on it, that 10 represents the type of curing agent you've got, which is the type 10. So I'll dispense up to the 10 because I'm using the type 10 curing agent. If you were using the sister epoxy to this, which is AE15, you would dispense up to the 15 mark for that AE15. I'm going to go to 10 because, again, we've got M-Bond AE10. I take the cap off of the curing agent, take the dropper, reach down inside, squeeze the air out, put some of the curing agent back in. You want to get it right at the bottom of the bubble. If you squeeze out too much, do it again. You want the bottom of the bubble to be right at that 10 graduation. It's going to be hard to see in the camera, but that's about where I've got it. So once I'm happy with that, now I'm going to take that and just drop it right into the center of the jar of resin. And these are not considered to be reusable. So once you use it, you take it and you throw it away. The curing agent is reusable, so you put the cap back on it. And now we take our plastic stirring rod and we start mixing it. And if you ask me how long you mix it for 5 full minutes. All right, so once you've mixed the epoxy for 5 minutes, typically if you were going to meet only the minimum cure for the AE10, which would be 6 hours at 70 degrees Fahrenheit, if you were only going to meet that minimum, then once you mix it for 5 minutes, let it sit another 5 minutes and then you can use it. In our case, we're going to let this cure overnight. So we're not going to wait that additional 5 minutes. But my 5 minutes of mixing time is in. Whenever you're using AE10, when you look down in it, you'll see that you probably have whipped in some bubbles into the epoxy. Don't worry about that because we're going to use a technique to help squeeze those bubbles out. And that technique is to apply the epoxy both on the strain gauge and the flex circuit, and in this case onto the wooden bat. And then as we start to push the two together, we'll put some pressure on it, and that will squeeze out any of the air bubbles that you see. So with that being said, I'm going to take the tape here on the bat that's holding the strain gauge and the flex circuit and peel it back, exposing both of those. And now is the time to apply the epoxy, and we're going to apply the epoxy onto the bonding side of the gauge and the flex circuit. And in general, it's a good idea to wipe off the stirring rod. Sometimes you get a little bit of curing agent or a little bit of resin that's clinging onto it, so clean it off before you start to use it to apply the epoxy. And then I try to take it right from the center of the jar, and I'm going to put it on the strain gauge and also apply some on the flex circuit. Really just like that. And then I'll take the bat and kind of roll it around a little bit. I'll probably put a little more epoxy on it than what I need, but it's a pretty good size area with the flex circuit. And I'll just kind of roll it around a little bit more. Just like that. That's probably quite a bit more than what we really need. I'll take it and pull it over and see that I've got it covered, and I do. So once I have the epoxy applied, the next thing I'm going to do is just take a gauze pad and just fold it, and then fold it in half again, and use it sort of like a squeegee, almost like if you're squeegeeing off a tennis court. I'm going to take this and just kind of put a light pressure and squeeze out that epoxy and just continue wrapping the tape around the surface of the bat. So basically when I do this, that's what's going to be squeezing out any of the air that you might see in the epoxy. I'm going to take that and move it to the side. Now the next thing that we need to do is put pressure on it. So with this epoxy, with AE10, it needs anywhere from 5 to 20 psi clamping pressure, and that needs to be on during the entire cure cycle. So I've got a piece of silicone rubber that I'm going to lay over top of this gauge and the flex circuit. Try to get it centered right over top of those. And then I've got another little shaped metal plate that I'm going to put over top of the silicone rubber. So I've tried to shape that into the same radius as the bat plus the silicone rubber. So that's going to go down next. And then now we need to put some clamping pressure on it. And in order to do that, I'm going to use this spring clamp. So I've got a spring clamp. In general, these produce about a 15-pound force. I'm going to take that, put that right in the middle, the best I can get it, and let that squeeze that metal plate down over top of the rubber pad, and let the rubber pad put the pressure over top of the flex circuit and the strain gauge. And basically you're at a point now where you let it sit 4 to 6 hours at 70 to 75 degrees Fahrenheit. That's really the minimum. In our case, we're going to let it sit overnight, and we can come in tomorrow, attach the wires to the strain gauge, and hopefully start doing some testing and see what this bat does as we start to take some swings. So that really completes the gauge installation process. Again, now we're basically in a holding pattern waiting on the epoxy to cure. Some of you might be thinking, could I have used a cyanoacrylate adhesive like our M-Bond 200? And if you were going to use this on a material that's more porous like wood, you probably want to put down a layer of pre-coat. You could use the AE10 to do that, and then you could bond the strain gauges on top of that using the cyanoacrylate. But in general, cyanoacrylates are not very good on surfaces that have a lot of texture or that are porous, because it really doesn't do a good job of filling that porosity. Cyanoacrylates, really, for them to cure properly, they need to be in a thin film, and when you start building them up thicker, oftentimes that's when you start to have problems. So we didn't use that. If we were to use that, the good news is we'd be basically done with the curing, but with AE10, we're going to let it sit overnight, come back in tomorrow, wire this up, and then go hit some pitches and see what happens. So if you'd like to find out more about gauge installation on wood or composites or plastics, feel free to take a look at our website at www.micro-measurements.com, and we have a wealth of information available on the website that will walk you through gauge installations on various materials. Thank you for the time.